My name's Gerald Cooper. I run, along with my wife and a few other people, Newquay Honey Farm just up the road in Newquay. And I'm going to try and talk to you this morning about two things, so it's double value for money. You get two lectures in one. One is how fantastic bees are, how absolutely incredible they are, and how we've got a problem, not with bees actually, we've got a problem with ourselves because we are losing it as far as our relationship to the natural world is concerned. And I'm going to try and point to a few things that we can do in order to try and redress that. Now, you'll have to bear with me because I'm not used to speaking in front of a microphone. I normally just charge around the stage and bellow at people when I give talks, and I don't have this kind of technology either. So it's going to be a bit stilted to start with. I've bought some pictures because I want to show them to you because they've got some really great things on them. First of all, that's where Newquay Honey Farm is. I hasten to add, this picture was not taken this year. It was taken after a period of severe drought in actually 1995. That's a close-up view of the place. It has a shop and a tea room, and it has an exhibition in the top floor. It's actually an old chapel, which tries to explain to people how important bees are in the environment and how wonderful they are as creatures. There's some of our hives. We have nearly 500 hives all over Ceredigion. These hives are actually in an old sandpit in the Arun Valley, and you can see it's pretty overgrown. You try and put hives where there's a lot of wild stuff. You don't want fields of endless grass where people have put lots of fertilizer on. So river valleys, coastal areas, places like that are really good places to keep bees. Here's another one. This is actually in a village called Talgarig, near the start of the River Cletur, usually in groups of 10 to 12, mainly for ease of management. What we do actually is we put the bees there and we try and do as little as possible to, in the way of beekeeping. There's a lot of beekeepers actually are forever looking in their bees and trying to manipulate them and trying to modify the way they behave. And what we try and do is leave them where they are, and we just go and look at them really for two reasons. One is to make sure that they haven't got any health problems, and that's an issue which I'll be coming to later. And the other one is that we sometimes need to make increases, and therefore we need to take some frames out of some hives and move them into another. Actually, you can see on this, is there a, yeah, down here, you see that one there? You see, is there, yeah, there it is. That is actually an empty hive. That probably died out in the winter. And actually, that one there is also an empty hive. So, what do bees look like? We have a lot of people. The honey farm has about 40,000 visitors a year. And people come in and say, so what are bees? Are they those big furry things? And we say, yes, they're bees. Those are honeybees. No, those are bumblebees. These are honeybees. Fantastic creatures, evolved 35 million years ago at the same time as flowering plants. That is a frame. Well, you can just see the wooden frame and you can see the beeswax comb. Where the cursor is, just there, you can see those are wax cappings, and underneath those wax cappings are larvae which are pupating, and after 21 days from the date the egg is laid, they emerge as honeybees. 60,000 bees in one hive. This is a hive made of wood, like, renewable, etc. Here's another picture of the same hive actually, and if I can get the cursor in the right place, yes. There's the queen. All these bees that you can see, with one or two exceptions, are worker bees, infertile females, and the only fertile female in this hive is that queen there. She is capable of laying up to 1,500 eggs a day. She lays more than her own body weight in eggs every day during the laying season, and she is fed royal jelly throughout her life. So people think, well, if it can do that for her, what's it going to do for me? And that's why people think that royal jelly is a good thing. Here's a wild colony. This wild colony, it's not managed. It lives in a tree trunk. It actually lives in a tree trunk in our exhibition. You can just see the wood at the top. And if you look at the very top right-hand corner, you can see a piece of barbed wire that was stuck to the tree when it actually lived outside. You can just see the ribs of the honeycomb that the bees live on. These are made of beeswax. The bees make the hexagonal cells out of beeswax, which is exuded from glands on their own body. And this structure is capable of holding 20 times its own weight in honey. It is the most mathematically efficient way of storing a substance in a structure. And it was only proved by MIT about 5 or 6 years ago, but this structure evolved 35 million years ago. Bees get out occasionally. Here they are, on a post. They swarm. That's how they reproduce. What actually happens is that the old queen and about a third or half of the bees leave the hive and go and settle somewhere, in this case on a gatepost, and they will then send out scouts and they will look for a new home to start up. So you've got the old queen and a load of bees there going off to find a new home. In the hive, they're building queen cells, and eventually a new virgin queen will emerge in the hive. She will then fly out, she will mate with up to 20 drones, and she will come back with enough sperm inside her to last her whole life. And if you're going to lay 1,500 eggs a day, you need 20 drones. These send out scouts to look for cavities in which they can start a new hive. Scouts go into a cavity and they walk around it. They perform a kind of calculus about how big is this hole and is it the right shape and size. And if they are satisfied, they will come back and they will do a dance on the face of this bunch of bees, which indicates the direction that this cavity is. And other bees will observe this dance and will also fly out and check this out. And if they think it's good, they will come back and do this dance. And eventually, so many bees will be convinced of the suitability of this particular nesting site that there'll be so many bees doing a particular directional dance on the face of this bunch of bees that they will all take off and fly into whatever it is, somebody's chimney pot, a disused television, a hole in a tree, or wherever they've decided is a good place to live. It's quite extraordinary behaviour when you think that they can actually communicate these preferences to one another, and they take off. People who observe swarms, I don't know if anybody's ever seen swarms in the air, will say, my God, it was amazing, the sky went dark, you know, we wondered what was happening. And they fly off and eventually go into the new home. They have a hell of a job ahead of them. They have to build the wax combs, which you saw in the previous slide, and they have to fill it with enough honey to last them through the winter. And in a study done in the northeastern United States, it was found that approximately 46% of swarms do not make it through the first year. So, one of the things you find out if you, get familiar with bees and you understand how they work is that bees and a lot of insects live on the margin. It is not an easy life being a social insect. It is tough out there, and there is a lot of death and lack of success. There is no easy life. Okay? This is a beehive that we keep our bees in, right? It is approximately the right size. Studies were done of what size cavity do swarms preferentially seek. And they found out that, roughly speaking, bees prefer a cavity about 40 litres in size, which is about what this is. 60,000 bees are capable of living in that, and this is what it looks like when you take the lid off. Bees everywhere. I've been with beginners who said, "Oh, Gerald, can you come and have a look at my bees?" And you go along, and it's the middle of the summer. The last time they looked at it was when they bought them the previous year, and it was probably quite a small colony. And you take the roof off, and they go, "Ah, my God, what's happened?" I mean, you can see they're pouring over the side. They're everywhere. And you can see, if you look carefully, that there are actually two sizes of bee. And they're workers, which are the females, and drones, which are the males. There's usually about 2,000 or so males in a hive. They don't do any work, and they only actually exist for sex. They fly out in the middle of the day and congregate in certain areas called drone congregation areas. It's a bit like, guys on the street corner going, "Oh, don't fancy yours." And they wait for virgin queens to turn up. And when virgin queens turn up, they fly after them. They have very powerful flight muscles and very big eyes so that they can see them from a long distance. And they mate with them on the wing. And there's some amusing stories about scientists in California who tried to replicate this by tethering queens at various heights to see whether drones would chase after them and mate with them. And there is actually a critical height which virgin queens have to fly at in order for drones to mate. And one time they got this height wrong, and a passing butterfly got rogered senseless instead. So they fly after the virgin queens, and the unfortunate thing is that once they mate, their genitals explode, and they drop down to earth dead. And then another drone comes along. Now, obviously, they don't know that this is going to happen. Otherwise, they, probably wouldn't be quite so keen. But if you think about it, that has to happen in order for the virgin queen to multiple mate. She has to mate with as many drones as she possibly can in order to store sufficient semen to last her whole life. She flies back to the hive, and she then takes up the position of the new queen in a hive. So you've had reproduction taking place. You've had the swarm leaving and a new virgin queen emerging from the old hive, going on a mating flight, flying back, and taking up a position as a new queen. We actually rear queens, and here's a picture of, these are very, very small hives. That comb is about that big, and you can see, you should be able to spot the queen straight away. I'm going to move this cursor down, and there she is. Lovely golden brown new queen, and if you look very carefully there, you can see there's an egg she's just laid. That egg has just been laid. The reason you can tell is because that egg is standing up. What happens is she lays an egg, and as you can see, compared to the size of the queen, they're actually quite big. And if you're laying 1,500 of those a day, you know you need looking after. That egg has just been laid, and after a while, they fall over. And then after 3 days, they hatch out, and then it becomes a larva, and then the bees seal the cell over, and the larva pupates, and it emerges as a adult worker bee. Here we are back in the apiary. That's me in the green, it's actually called sage, bee suit, and there is a Central Science Laboratory, DEFRA bee inspector with me, and we're looking in this hive and we're trying to find out what's wrong with it, because it's, you know, there isn't, it's not happening. This is actually the same apiary that you saw at the beginning, and I'm going to talk for a brief time about what actually is going on with that hive. As you can see, you know, it's this is the thing about keeping bees. We're looking for a problem. Okay, that's bad, but it's fantastic. You know, you're out there in the countryside, you're working with this incredible insect, and it's just very, very enriching personally. Here's another apiary. I don't know why I put this in. This is somewhere else. Row of beehives. You can see we've actually just looked through those beehives. Someone's left the smoker behind. And you can see the bees up the front. You can see actually from this picture that we started at the far end, and there's very few bees on the front of those hives. And as you come nearer, then there seem to be more and more bees because we've only just closed those up. So that's bees. Then, of course, there's this. That's honey. That's a frame of honey. Bees store honey, and in fact, they can collect colossal quantities of honey if they are given the room. I know a guy in Canada whose 10-year rolling average is 225 pounds of honey per hive. Right? In this part of the world, it's probably about 20, and this year it was probably about 4. But you know, there we are. What you do is there I am, blue gloves, health and safety, all the rest of it. You cut the cappings off, go quickly through this. There's a frame of honey. The best thing in the world. Fantastically concentrated source of energy, pure plant sugars, 110 different other substances, trace elements, proteins, enzymes, all sorts of things. If I catch anybody drinking Gatorade, I'm going to kill them, because honey is much, much better. We put it in this thing. This is a 36 frame extractor. There are the frames. They're put in like vertically. We turn the motor on. It whizzes round at the speed of light. The honey is flung out against the sides of the extractor, and then we put it through a cloth to strain it. The difference between our honey and the honey of other small-scale beekeepers is that it is strained and it is not filtered. One of the methods of filtration is to dilute honey 50-50 with water and then pump it under pressure through fuller's earth. That way you get rid of most of the pollen and a lot of the other substances, and you might just as well eat golden syrup. You've really destroyed the food value, but the advantage is that when you put it on the supermarket shelf, it won't granulate, it won't go cloudy, it looks all right, okay? But if you want something that's real food, that does you good, you have to get local honey from somewhere. Here it is. Look at that. This, forget about the bread, you know, that's rubbish. You know, make your own. right, like I do, and put honey in it because it keeps it moist. All right? But that is fantastic honey. Now, I thought I'd tell you that there's only one graph today, because like last night it was... Here's an interesting, interesting graph. You've had an article which shows you that honey production is, that the carbon footprint of honey production is extremely, extremely, extremely low. And here are some comparisons. I don't quite understand this graph myself. I didn't understand any of the graphs last night. If you buy chocolate, right, your chocolate bar has used virtually as much gasoline or energy as there is in a barrel of gasoline to produce it. If you buy raspberry jam, as you can see, it's what, I don't know, about a third of what you have for chocolate. Sugar, it's pretty bad. Imported honey, it's all right, but the news is not good. Local honey, the amount of energy required to produce it is much, much lower. And there are other benefits from buying local honey, which is the ones I've already mentioned, that it's actually a better food for you. But the energy required to refine sugar and do things like produce chocolate is phenomenal. It says in the article, I think it's either 40 or 60% of all the energy used in the food industry is used to produce sugar from either sugarcane, sugar beet, or cornstarch, right? And if that wasn't done, the amount of energy use in the food industry would be virtually halved. So what I'm trying to say to you is that that's what's so great about bees. You've got this fantastic insect which evolved 35 million years ago, which if you keep bees, you can actually become involved with. It's an amazing experience because you cannot do it on your own terms. This thing has its own agenda. Bees operate according to rules laid down before man was on the earth, right? And a lot of beekeepers think, yes, you know, I'm going to be a legend in my own lunch hour. I'm going to work out how to control swarming. I'm going to do this. I'm going to do that. And everybody comes to grief. You have to let bees go how they want. For instance, we don't try and stop bees swarming because the books are full of ways in which you can prevent bees from swarming and you can avoid them swarming and so on and so forth. But actually, think about it. What do bees want to do? They want to reproduce. Of course they're going to swarm. There's a saying which I always hold to, and that is, always push the bees the way they want to go, because it's great, you know. They're doing what they want, but there's a funny way in which you also feel in control and part of it. So it sort of works. A lot of people come into the shop and they say, yeah, there's a problem with bees, isn't there? I've been hearing about this. And they're all dying, aren't they? And they've got, is it a virus or what? And you sort of say, well, no, it's not quite like that. It's actually more complicated. Things are complicated. You know, when you're dealing with an insect which doesn't have remotely the same kind of way of life that as mammals, things do get complicated. So I'm just going to run through very briefly what people have been talking about with this. There's this thing now which is called colony collapse disorder. Okay, so it starts in the United States. What happens is people notice in the middle of summer that they come back to their hives and there aren't any bees in them. All you've got is a queen and a few young bees. Now, you saw the picture of the hive, 60,000 bees. You imagine coming back and there's a handful of bees there. What the hell's going on? The other thing that's happening is that those hives appear to be shunned by other insects, parasites, because usually empty hives are infested with things like wax moth, who like to eat the wax. You get other insects that come in and eat the debris on the floor, and all sorts of things happening. You know, it's kind of quite a jungle inside a beehive. But these hives are like sterile. There are 2.5 million beehives in the United States. Last year, 750,000 of them disappeared in the middle of the summer, and nobody knows why. There have been lots of explanations for this, and people regard it very seriously. Pollination of crops is extremely important in the United States. It's worth $15 billion to the food industry. In Southern California, there are thousands and thousands and thousands of acres of almond trees. That's all you can see. Of the 2.5 million hives of bees in the United States, last year, 1.3, half of those, were trucked into Southern California to pollinate almond trees. Because otherwise, you don't get a good nut crop. They're on big trucks. They're stacked up. It's like skyscrapers. They have a net thrown over them. The trucks are wheeled into the field. The trailer is left there, and the tractor unit goes off and probably gets another load. Why do they do this? There are a number of reasons. One is, and these are things to think about in relation to, you know, how agriculture is going and how all sorts of things are happening in the natural world. One of the reasons is that there's this huge area which has simply been given over to almond cultivation. Now, that's a very, you know, unnatural state of affairs. It's a European species. There are no natural pollinators of almond trees in the United States because the honeybee is not a native of the United States. It's an old world insect. It was never in the New World. So they're all like visitors, if you like. So they have to truck them in. So this is like, you know, a serious problem for American beekeepers. In the next 2 years, they reckon that the requirement for the almond crop is going to be not 1.3 million hives of bees, but 1.5 million hives of bees. But they are losing lots and lots of bees. Some beekeepers have lost 90% of their colonies, and nobody knows why. There are lots of theories. Probably heard about, you know, mobile phones, GM crops. There's a new disease which has come in because of buying bees from Australia, because they import a lot of bees from Australia because they lose a lot in the winter, and there's all sorts of things. These bees are also important because they also pollinate other crops. They go on to things like zucchini, outdoor tomatoes, orange orchards, and curiously enough, cranberries. So, you know, the whole world decides that cranberry juice is a great thing. The cranberry acreage in northeastern United States expands enormously, and they need bees to pollinate them because you get better berries. So these bees are in Southern California, and when they finish doing the almonds, they're trucked all the way over to the northeastern United States to pollinate cranberries. This is not a good life for a bee, and a lot of people are saying that, you know, that this is where the problem is. So there are issues about what is happening to the bees in the United States. Let's move over to this country and talk about what's happening here, because there are serious problems here as well. Someone I know took 220 hives of bees over to fields of borage, which is a herb which is grown for its oil, in Lincolnshire. He went back 2 weeks later, and of those 200 odd hives, 170 were dead. In the middle of the summer, this is completely unheard of. There is one possible explanation which is obvious, and that is pesticides. That was ruled out. Nobody at Central Science Laboratory which is the organization which deals with bee health, had any solution, any ideas. A conversation with the head of Central Science Laboratory in September with this person went like this. I understand that a laboratory in Spain has discovered a new form of nosema disease which is decimating hives in Europe. Could it be that? No, we haven't got Nosema cerana in this country. Well, could you have a look to see if maybe some of my bees in my dead hives had Nosema cerana? No, well, we haven't got anybody trained up for that, and we haven't got any money to do it. We need to actually bid for a pot of money from central government. Then we need to find somebody, you know, who's doing a PhD or something like that, who can then work out how to look for it under the microscope and so on and so forth. There's a laboratory in Spain that knows how to do it. Can we send some of my bees there? No, we can't do that. Spain? Good God. By Christmas, Central Science Laboratory had come to the conclusion that there was Nosema cerana in this country and that it had been here for 2 years. Now, what is the point of having people with that kind of attitude to dealing with a particular problem in bees if their way of doing it is to follow certain bureaucratic patterns? Losses this winter among beekeepers have been at about 5%. Sorry, 10%. There are 250,000 bees in this country. In 1940, there were twice as many colonies as that. And the number of colonies is shrinking because the number of beekeepers is shrinking. And the problem is that there are fewer bees in the country. There are two things I want to say. The guy keeps holding up his hand saying 5 minutes. So what I'm going to do is I'm going to finish with this. The problem is not actually for bees. I said originally that bees actually have a really tough time and they are used to, you know, quite high levels of mortality and so on and so forth, right? Now, there have been collapses in the bee population before, in 1880, in 1920, and in 1960. The way bees work is that when there is a new threat, a large number of bees will die. Some will not. They are more resistant. And the bee colony will grow from those more resistant strains. And that has happened with lots and lots of insects. And you just have to think about the attempts that man has made to eradicate certain insects and how he has failed to do that, to see how bees and other insects are actually very resilient to the kind of stresses that they are put against. The problem is that we are losing our contact with the natural world because we rely on someone like Central Science Laboratory to actually come up with ideas about why bees are dying, and all they can do is follow what you might call the bureaucratic process. And there's a brilliant quotation which I'm definitely going to read you at the risk of going over time. When asked if DEFRA could supply more money so that this problem could be investigated, a spokesman said, "The emphasis is about identifying priorities for action within existing resources. If the consultation identifies clear pressing needs for additional resources, this will need to be considered during the subsequent implementation phase against other priorities. This would need to include consideration of the most appropriate sourcing of any funding needed." Meanwhile, bees die, nobody knows what's going on, and so on. We demand a lot from bees, and we rely on bees. Pollination in this country is worth £200 million to the agricultural industry. And we have that kind of dim-witted response on the part of people in government. So I'm going to finish now. What is the answer to this? Firstly, keep bees. If you can't keep bees, provide habitats for bees. That's what a lot of these leaflets are about. Join organisations like Plant Life. There's another leaflet about woodland conservation. These are very, very important environmental things that anybody can do.